Hello everyone, this is Abhishek here, and today we are going to discuss about Karastuba algorithm. The Karastuba algorithm, named after the inventor Antonelli Karastuba, is a groundbreaking technology for multiplying large integers. It is a cornerstone of computational mathematics, significantly optimizing the process of multiplication, especially when dealing with the massive numbers. Unlike traditional methods, which involve multiplying each digit individually, the Karastuba algorithm employs divide and conquer strategy, breaking down the multiplication into smaller subgroups that can be solved more efficiently. This approach allows for a remarkable speed up in multiplication, particularly for number with a large number of digits. Motivation for fast multiplication. In various fields like cryptography, computer science, and scientific simulations, the need for effective multiplication arises frequently. When dealing with large integers traditional multiplication methods such as standard long multiplication algorithm can become computationally expensive and time consuming. This is especially true for numbers with hundred or even thousands of digits. The Karastuba algorithm offers a solution by leveraging a recursive approach to reduce the number of multiplications required, leading to a significant number improvement. Efficiency reduces the number of multiplication needed, saving time and resource. Scalability handles large number more efficiently than traditional method. Application used in cryptography and computer science and scientific simulations. Divide and conquer approach. The Karastuba algorithm is a prime example of divide and conquer paradigm. This approach breaks down a complex problem into smaller, more manageable sub-problems that are easier to solve. The algorithm then recursively solves these sub-problems and combines the result to obtain the solution for the original problem. This recursive breakdown ensures that the algorithm can handle increasingly large number efficiency divide. The input number are split into two halves of equal size or nearly equal. This divides the original multiplication problem into smaller subproblem. Conquer. The smaller subproblem are solved recursively using the Karastuba algorithm itself. This process continues until the base case is reached. Combine. The results from the subproblem are combined to obtain the final result of the original multiplication. The steps involve pure algebra manipulation to minimize the number of multiplication required. Base case multiplication of single digits. The base case of Karastupa algorithm is when the input number are single digit. In this case, the algorithm performs a simple multiplication just like a typical multiplication operation. This is the foundation of recursive process as it involves the terminating condition for the recursive calls. The algorithm stops when it reaches the base case, returning the result of the single digit multiplication. Recursive step recursive step multiplication of multi-digit number. The recursive step of Karastuba algorithm handles the multiplication of multiple digits number, and it breaks down the input number into smaller halves and recursively applies the Karastuba algorithm to multiply these halves. The key insight is that by carefully rearranging terms, we can achieve the final product using only 3 multiplication instead of 4. This reduction in multiplication is crucial for efficiency of Karastuba algorithm. Split. Divide each input number into two halves of equal size or nearly equal. Multiply recursively. Apply the Karastuba algorithm to multiply the halves into the input numbers. Combine the results from the recursive calls using algebraic manipulation to obtain the final product. Karastuba insert reducing the number of multiplication. The genius of Karastuba algorithm lies in the clever rearrangement of term to reduce the number of multiplication needed. Let's say we want to multiply two numbers x and y, each with n digits. Traditional multiplication requires n to the power 2 multiplication. Karastuba insights allows us to express the production xy using only 3 multiplication of smaller numbers, leading to a significant improvement efficiency. Example in traditional method and Karastuba methods. Implementation of Karastuba algorithm. The implementation of Karastuba algorithm involves defining a recursive function that takes two input numbers x and y and returns their product. The function first checks if x and y are single-digit number. If so, it returns their product. Otherwise, it splits x and y into two halves recursively, calls the Karastuba functions to multiply the halves, and combines the results using the algebraic manipulations described earlier. The recursive nature of algorithm makes it elegant and adaptable to handling numbers of varying size. Here is an example of Karastuba algorithm in C programming. Time complexity analysis. The time complexity of Karastuba algorithm is significantly better than traditional multiplication algorithm. It has time complexity of O n power log 2 3, which is approximately O n power 1.58. This means that the size of the input number increases, the algorithm's runtime grows at much slower rate compared to the O n power 2 complexity of traditional multiplication. This makes the Karastuba algorithm highly efficient from multiplying large numbers, faster than O n power 2. The Karastuba algorithm has a complexity of O n power log 2 into 3, making it significantly faster than traditional multiplication algorithm. Logarithmic growth. The algorithm runtime growth normally makes it efficiency for multiplying very large numbers. Improvement in Karastuba. Improvement efficiency. The Karastuba algorithm reduces the number of multiplication required, leading the significance. Advantages and limitations of Karastuba algorithm. The Karastuba algorithm offers several advantages over traditional multiplication method, and its most prominent advantage is reduced time complexity, which makes it highly efficient for large numbers. However, it also has limitations for small numbers. The overhead involved in splitting and combining numbers might negate its speed advantage. Additionally, for extreme large numbers, even more efficient algorithms such as fast four transforms based multiplication might be more suitable. Fast time complexity for large numbers handles number with hundreds or even thousands of digits. Thank you.